We're here to solve this Sunday stumper by Prasanna Seshadri. It's a Kakuro variation we haven't seen much of before, and I think half the challenge will be figuring out how to use the new rules. I think I'll actually start in this video by just turning on for myself surface. I'm going to want to color some stuff to help show some things, and Sudoku normal, which is a starting point to just put in clues. To start introducing the rules, like a Kakuro subset, for instance, this gray clue in the upper left corner, it's going to have either its horizontal entry or its vertical entry right after that clue intersect with another set that's going to have the same digits as a subset in one direction or the other. Whichever is the shorter clue will be a subset of the other, and if they're the same size, they'll be the same digits. And if you look at this horizontal, none of these vertical entries are part of a subset. The important thing in this puzzle is to recognize the black clues don't have those connections, and so this horizontal entry is not where a subset exists. This vertical entry is, and the only row it can be a part of is this one. So one of the first things you can see in the start of this puzzle as you're trying to learn this rule is this horizontal entry of 4 cells, which sums to 26, is a subset of this vertical entry that's got 4 cells. So it also is 26, and it's the same numbers. And so that's an example of a starting point. Another one is right here in the bottom. This 10 doesn't have a vertical option, so it's certainly part of a subset. And this vertical clue in column 1 and in column 3 are black. So it's going to be this set, 3 cells, 3 cells. This is again going to be the same sum of 10 and the same digits across those groups. There are some others we might be able to mark. I think the one last key one is probably this 18 at the top. So it must be this horizontal entry because there's no vertical one from it. And of these columns, only this one comes through. And in this case, 35 and 5 cells is a maximum sum, so we actually know a fair bit about it. It's 5 plus 6 plus 7 plus 8 plus 9. And a subset of those digits, 5 through 9, will have to be what equals 18. And the smallest subset you can take is 5 and 6 and 7, leaving out 8 and 9. And you'll see 5 and 6 and 7 sum up exactly to 18. So that's how it looks like this puzzle starts for me, is in this upper right corner. And coming down this 35, this 9 clue can only take a 5 or 6 in this cell. If it were 7, it would leave behind 2, which is not possible in 2 cells. The smallest sum is 3, so 3 limits us to 6 or lower. And in 3 cells, the largest sum is 6. Sorry, the smallest possible sum is 6, so this is also a cell that's got to be 5 or 6. The maximum digit of 12 in 4 cells is 6 from 1 plus 2 plus 3 plus 6, or otherwise it's going to be 1 plus 2 plus 4 plus 5. Those are the 2 values for a 12. So I've got a 5, 6, 5, 6 pair. Got a 7 up here, which marks those in. I'm left with an 8, 9, 8, 9 in the other cells for this vertical clue. Now we've done a lot with the positive rules to look at gray cells. One thing I'm seeing here that's interesting is this 9 coming across is intersecting a 9 coming down. And so if we actually look at a cell like this, you might initially say this can be a 1, a 2, or a 3, where the large digit of the 5 or 6 are around, and then it's 1 plus 2 or 1 plus 3 to fill it in. But notice that this 9 coming down has to be a different set of digits that sum up to 9 than this 9 coming across. So if I actually made this be a 2, I'm forced to put 1s into both places and 6s into both places. That would not work out. And if I put in a 3 here, I'd simply have to put 1s in both places and 5s in the other places, and that would not work out. And so because these are different entries, the only place of 5 plus something, 5 plus 1, 3, and 6 plus 1, 2 intersect is the digit 1. So 1 has to exactly be in that connecting cell. 2 and 3 will be in the other cells, but let me color this in. Let me actually first remove all of these because I'm not sure this will be as helpful as we go forward. These digits in blue are different from these digits in green. And in particular, this blue 5, 6 will be the same digit. If this is a 5, then this digit's a 5. And if this digit's a 6, then this digit's a 6. So these blues are a shared set. These greens are a distinct set from each of these digits. And you can mark this differently on paper, but kind of want to color that in here to get that constraint into the grid. We've got some other places where that intersection rule is going to play out, and I actually think I haven't looked down here in the bottom yet, but both of these rows have some pretty forced values, so let's go ahead and think about them. First, this 17 in 2 cells is always 8 and 9, and 23 in 3 cells is always 6, 8, 9, so that's a good way to start. Notice that 8 and 9 is a pretty small sum. There's only 2 cells. But it's intersecting this very large 5-cell sum that's got all these other cells around it. And let me go to a better color to separate. Let's go to yellow with red. Notice that whatever digit is in this red cell here cannot be anywhere else in this yellow group. And that's because this 8, 9 is not a subset of the digits in the 30 clue. So this may not be something you'd immediately see, but once you get used to the puzzle, if this were an 8, now red is a subset of yellow, that's not possible. If this were a 9, this is still now also a subset of what was there. And so the thing to observe is that 8 and 9 can't go in that cell because whatever is this digit is not in the rest of that column. And so 6 is exactly in that cell. 8, 9 come across. That actually means that this vertical clue is a subset of this 8, 9 going across. So we've fulfilled that, so that looks good. But that exclusion is one key criteria for what's going on in the space. The next thing to think about is actually that because we can only take 9 or 8 in this column, but not both of them, we've got a pretty limited set of sums to get all the way to 30. So let's think about what those are. If 8 is the largest digit in this column, so if this cell's an 8, then it has to be 8 plus 7 plus 6 plus 5 plus 4 to get the 30. And if 9 is in the cell, then we have to skip over 8. So we get 9 plus 7 plus 6. That still looks okay. That's 22, and then it's going to be plus 5 plus 3. So in this column, there'll be 3 and 4. And let me figure out sort of where I want to mark those. We're going to have 3 or 4, and then we're going to have 5 and 7, and then we're going to have the 8, 9 already taken here. So all the remaining cells in the space can only be from this set of digits. And actually, for this 12 clue coming across, this cell has to be the 3 or the 4, which is the smallest digit in that set. And the remaining ones are 5, 7. So this is a hard sum to break apart, but this is the way it can be broken apart logically in the grid. It's got its largest value here. It dodges 8 or 9 for the rest of the column. It has its smallest value here, and these collectively will add to 12. That will always be true. And then 6 and 5, 7 complete it out. So if you figured out or can see sort of how to break that in, you're doing pretty well with this puzzle style to get what's going on. To complete a 12, the rest of these digits have to be 1 and 2. And hopefully that's a good way to break in there on that side. I've got more I can do in different spots of the grid. I've got a little I can do in the lower left, but let's come back to the upper right for a second, and let's look at something I didn't do at the start. So this whole group in blue, again, this 5, 5, or 6, 6 will be the same here. Notice this cell here cannot be a 1, and it can't be a 1 because of the fact that this column is not a subset of this column. So where every other cell right now that's in this vertical space is shared with what's in blue, we're going to get the fact that this is not a 1, so this is some value coming higher. And from an 8, 9, leaving behind 12 or 11 in this row, like this can go as large as 6. Over here we have something like 4, 5, 6 coming through. And so that's actually going to be even an additional constraint in this set, which I'm trying to see how this works out. It will still sort of affect the smallest digits, but let's come back exactly to this cell. And so this 20 across, whether this value here is 8 or 9, is going to leave behind a sum of 11 or 12 in 4 cells, and either of those values requires a 1 in it. And this is the last cell in this row that can be a 1, because we can't put a 1 here because it's not a subset of this clue. So this is a 1. That now propagates down here, this to be a 2, this to be a 1. We get a space, let's sort of just keep working through this progress. We get a space where we've got 18 so far in this row. Sorry, this column clue, and that means we got a sum of 11 to still fill in. That can be 4 and 7, or it can be 5 and 6. We need to make these clues work together to fulfill a 17, and these are getting pretty big. Actually, if I had a 5 in the cell, which would put a 7 there, again, this would eliminate together. That would take 12, and that would leave behind only 5, so that's no good, so 5 can't be here. And also if a 7 were here, it would put 5 over there, and that'd be the same issue. So this is a 4 or 6, which means the actual other digits here, if this were a 4, this will be a 7. If this is a 6, that will be a 5. We now have actually made a 5, 7 pair coming across. That's pretty interesting. Let's see if we can take this one step farther. So this is 4, 7, 5, 7. This is worth 11. If this is 6, this is 6, 5, 7, 5. This is 11. So this group coming across is always 6 in 3 cells. So it's 1, 2, 3. And that's now going to put some constraints on the sum coming down. So this is 8 or 9. 8 in the small n with another 1 would be 8 up here, or 7 or 6. And 9 with a 1 would be 7. 9 with a 2 would be 6. 9 with a 3 would be 5. So this range allows 5, 6, 7 in these cells, but 5, 7 are already over there. So this is a 6. That now actually means this has to be a 2 or 3. We still have some stuff to do here, but this looks like this will be a partner to that clue of 2, 3, 4 to get the sum to work out. And we don't know much yet on the cell, but it's going to have to be part of a valid 12, and this 12 is going to be a subset of something coming across. So we can probably use that pretty soon. Let's come back a second to the top, and actually, I think I missed this when I first did this, but it looks pretty key. These green cells, this 2 and 3, are different digits, so this will be 2 and 3, and so this cell can't have a 2 or 3 in it because it would be the same as one of these digits. So this is a 4, 5, or a 4, 5. We now come back to, again, having a sum of 11 or 12 for this whole space, depending on what the 8 is. Both of those need a 2. And so the only space in this row for a low digit that's as small as a 2 is this one. So 2 is with 6. Blue is a different digit. So this is 5. We get 3. We get 5. We now are going to have the smallest possible sum still in this row be 1 with 2 with 4 with 5. And that's going to force an 8 here. And that's going to mean that this sum coming across has 4 and 5 as remaining digits. There's a 5 up top here. So this is 4. This is 5. This value must be a 9. This value is a 6. This value is a 3. If this is a 3, then this had to have the larger value here in red. So we get this propagating over, get a 3 coming down here. That puts this in. The 1, 2 actually now eliminates the 2 as a cell there. So this looks like pretty good progress. Before we overrun it, let's recognize this 12 coming down as a different set than this 12 going across, because this clue right here is black. So this isn't 3 and 6, this has to be 4 and 5, so that this subset is distinct from this subset. That now means this will be the smallest digit of this group coming across, which will be either an 8, 6, so like 9, 5, 8, 6, or 9, 4, 8, 7. Notice this clue here is also black, so this group is not a subset of this group. So I always have to have a smaller digit than 5 in this group, or this won't work. So this must be a 4. If this were a 5, we'd have 6, 8 remaining, and then you'd see pretty clearly these digits are exactly the same as those. So this is a 4, this is a 5. This will be 7, 8, 7, 8. This 5 is actually forcing this whole group to be 9, 8, 6. So the 8 is here, the 7 is there. We get 9, 6, 9, 6. We just made some progress down below, so let's look at this. Notice that this whole horizontal thing is not a subset of anything else. And if this were a 3, these two cells would be a subset of this whole clue. So from the inverse of subsets, we have to dodge this cell off the 5 clue being a 3. So this is a 4, get a 1, get a 2. Those all look fine. This horizontal group, though, is a subset of something coming across. And notice right now it can't be a subset of 863, can't be a subset of 189 something, because there's not enough space for an 8 or 9 over here. And it can't be a subset of this whole group, because there won't be space for a 9 and a 3 as missing digits. So this is a subset of something vertical. The only option left is the 4 and the 1. So this has to be 4 if 1 there. And we now will need to figure out how do we get the last set of digits resolved here. And I think the way that goes is we have one clue that we haven't, we've got, let's see, this is a subset, clearly this cell is a subset from this direction. So it's not about the subsets per se, but it is going to be about probably dodging a group that's intersecting here. So let's think through what that means, and it's going to likely come from this 12 clue coming down, and what is the key consideration here? Oh, here it is. If this is 1, 4, we can't have a 4 in the cell, because then 1, 4 would be a subset here again. So this is 6, this is 5, this is 7, this is 5. This is a Sunday stumper, so if I'm stumping myself while going through it, this is the intended experience. These are some pretty subtle deductions, but this 1-4 clue is pretty powerful in eliminating digits from here. And then again, this 4 eliminating that digit there. I've got this 12 coming up. It normally can be 1, 2, 3, 6. Notice that 1, 2, 3, 6 is already in the subset, so this will have to be 4, 5 that fills it out. There's already a 5 here, so this is 5 and 4. Then this is not a subset of that. Everything looks okay. We haven't looked in this corner yet, but let's do that now. The 22 coming down is a pretty large clue. It's going to be 9 with either a 5, 8 or 7, 6. But notice a 9 can't go in a cell with an 18 clue that's 5 long. A 9 can't go in the cell that's got a 10 clue, so this will be a 9. And then this would typically be 5, 6, 7, 8. But what you'll see is a 10 clue can't take an 8 in it, and also there now is a 5 over here, but for the same reason we get kind of this elimination of 5, 6, 7. These are going to be the same digits as what's here. And a thing that this 5 forces is now some careful consideration here. It no longer can take an 8, which means this is not a 5. And if this is taking the 6, this will now leave behind 12 exactly, and will leave behind a set that has to be 1, 2, 4 in the set. And now see that these 4 entries are exactly the same as these 4 and the 12 coming down, but this 12 is not a subset clue. So 6 cannot be in the cell because it would force subset to be the same. So this is a 7, this is a 6. We're going to have 1, 2, 3 coming across. This 6 is going to have to be a 1, 3. And again, this set and this set will be the same. So because of how this needs to be part of a subset, we talked about that at the start. So a 6 has to be in this vertical clue. It's exactly there. That means this is 1, 3, 1, 3. This clue to get finished, this is a 3. Forces 1, 3, 1, 3. Puts in a 2, puts in a 3. So we're out to here now. We've got ways to think about this 18 that's vertical. We've got 6 taken, so we're going to need to get 12 more. That could be 4 and 8 or 5 and 7. Notice if 5 is in the space, it's if 5, 7 is what we do, then this 18 and this 18 would actually be the same digits, but this is not a subset clue, so this has to be 4, 8 coming up. And you'll see that a 4 is already over in the space, so 8 is down below, 4 is up above. This 16 clue coming down has 10 in it, so it needs to get 6 more. Normally that could be 2 and 4, but 4s are already blocked in both spots. So this has to be 1 and 5. That comes in and looks fine. We now have 9 in this clue coming across. It's going to be worth 26, and it looks like 8 and 9 are required there because we've got 17 left over. Remember at the very start of the puzzle I said these 4 vertical and these 4 horizontal are the same, so I'm just going to write in, now that I know the set is 4, 5, 8, 9, write those in and now think about them. In this clue we can't have an 8 or 9 because they'd be too large for a 10. If this is a 4, we get an 8 over here. If this is a 5, we get a 7, an 8 gives a 4, and a 9 gives a 3. If 4, 8 is in this group, this would be a subset of this vertical clue, because 4 and 8 are already in it, so I can immediately exclude 4 and 8 from these spots. And what I'm trying to see is if there's another exclusion based on that with what's surrounding. And I think here there's going to be some tension if this is a 9 and this is a 9. And so let me show you what I mean. If this is a 9, then these cells will always be a subset of these because these are the only digits that differ. So different way of saying that is whatever digits in this cell cannot be in this cell. And because placing a 9 in this cell forces a 9 in this other cell, this digit on the left has to be a 5. So this is a 7. That puts a 4 up above. And at least behind just 8, 9 as the options up here. Sorry, there we are. A 9 would put a 6 over here, and 8 would put a 9 or 6 over here, but 9 and 8 don't go together, so this always has to be small. And a 9 actually leaves now just behind 15, so 5 cells, 5 and 3 cells, that's not going to work, so this has to be the smallest end. So 8 and 6 are the minimum to put in here, leaves behind 1, 2, 3, which all works. That makes this an 8, 9, this makes this an 8. This 4 has 6 to go, which will have to be 1 and 5. And notice if this is a 1, then we don't have a large enough value here to make this an adequate sum. So this will have to be a 5. 5 with 1 would put a 9 up above. So this will be 2 for an 8 or 3 for a 7. This 2, 3 now has one spot left for its 1. Let's think about this total sum. We've got 16 with 2 to go. That's going to be 2 of 4. It can't be 3 there. Put in this 3. We got the 7. We're now left with, it looks like no sum information, but what we know is this is not a subset of these. So we're actually, this is a fun elimination. The digit in that white cell cannot be any of these in green, and it can't be the ones that see it directly in the same row or column. So all digits but 9 are eliminated there. So I just have to type in 5 and we should have the answer. So there we go. A pretty tricky Sunday stumper. In part, you just had to figure out how to apply the new rules. And then as we worked our way through the grid, a lot of subtle spots where this 9 and that 9, they don't share digits. This 12, they don't share digits. This 5 clue and this long clue don't share digits. This mini clue and these long clues don't share digits. So that exclusion rule felt to be pretty key for a lot of progress through the grid. And even then, some pretty complicated sum breakdowns, like this 30 vertically, we knew it had a 9 or an 8, but not both. And that meant we could have a 3 or a 4, but not both, to get a valid sum for that whole column. So a lot of different steps throughout. That's why it got the difficulty we called out, but hopefully you enjoyed the aha moments through. And if not, this video helped you maybe spot some things you'd missed. So thanks, Prasanna, for the challenge, and we'll see you again soon.